because, excuse me, that really is my intent. None of us really understand where generative AI is headed, but I thought that I would collect my thoughts out. The constraint I set myself was trends that I can see that are going to be even more important next year than they were last year. And number two, trends that weren't obvious to me in 2022 when we all first encountered ChatGPT. So I've identified some trends. I'm sure they overlap with yours, but I thought of. So the whole point here is to get our brains stimulated and then have a discussion. Okay, so let's just jump in. First of all, let's just take a quick look at what the current day LLMs, generative AI, foundational models can do. One of my favorite examples is that they can write mathematical proofs in the form of poems, which I myself cannot do. Here's one of my favorite examples. Right after GPT-4V became available less than 6 months ago, I took this photograph on my desk and I uploaded the photograph and I asked GPT, how can I stack these 4 objects in a stable vertical stack? And it responded like this, which really impressed me. To stack 4 objects in a stable stack, consider the following based on their apparent size and shape, and then it goes through and suggests a way to do it. So I followed the instructions, serving as the robot, letting it be the intelligent agent. And this is what I got. And it worked just fine. So despite the fact that GPT became famous for being trained on what we think is probably roughly 1 trillion examples of text extrapolation, it has somehow developed enough of a common sense of the physical world to be able to figure out that if I want to stack these things, that's what I should do. So that's, again, an example of today's technology. Here's another one of my favorites.
Common sense there. So how much do you think that is common sense versus that there have been like stacking things in the trillions of, items in the data set? I mean, I did this a little bit when I saw this coming out, and for simple stacks, it works. But if you give it something more complicated, you find that it hits the boundaries sooner than a human would, and can't figure it out.
Well, I have given it a limited number of these examples, but one thing that I explicitly did here was I put this thing. This is actually a golf tee. It didn't know what it was. Finally, it says, finally place the green object, which appears to be some type of plastic tool or toy on top of the coin. And also at the base, it says, start with the largest, heaviest object as the base. Here, the black rectangular object, which appears to be a case or a pouch of some kind, seems. So yeah, I think there's enough diversity and novelty in this collection that probably hasn't seen at least these exact.
Yeah, actually, and in fairness, this is, I did this maybe like a year ago. So this is maybe, it's getting smarter pretty fast.
I think it's getting better. Okay, so here's another example that actually was motivated by a time when I was sitting next to Eric in a meeting, and we decided that instead of paying attention very carefully, we would start messing with GPT. And so this is just a simple math problem. Suppose Mary drives, actually I misspelled suppose, but it figured it out. Suppose Mary drives from point A to B at 100 kilometers per hour. Bill drives from B to A at 50 kilometers per hour. And they both begin at the same time. Will the paths cross it? Yes. Where? It solves the problem. Yes, they meet 2/3 of the way. That's pretty good. But more interesting, then I said, suppose the student answers incorrectly that they meet in the middle. What would be a good hint? And it says, you could say something like this: remember, they're not driving at the same speed, so they won't meet halfway. Think about who's driving faster and how that affects where they'll meet. The faster driver will cover more distance in the same time, which is actually a great hint if you think about it. It's getting you to attend to the fundamental idea without giving away the answer. So finally then, I said, give the advice in the style of Taylor Swift's song. And here it is. And my favorite is the chorus, which of course gets repeated. The chorus is the hint. Before, you gotta focus on the distance they travel before they meet and their paths unravel. Mary's speed is faster, that's a fact. So halfway between A and B is not where they'll act. So, all right, it's another one of my favorite current state-of-the-art examples. You've all seen this picture, I bet. It's just inventory in green of how good GPT-4 is in a variety of exams, ranging from GRE, quantitative exam to AP English language, and so forth. So it's really quite good. And then, of course, there's the whole generative AI branch having to do with generating images, which seems wisely melding with is both GPT and Bard Gemini can produce images as well as consume them. All right, so that's just to kind of bring us up to remembering what the current state of the art is. And even though, of course, we can't really predict the future, what fun would it be if we didn't try? So here's some trends. And again, the constraint is, I didn't see this coming in 2022 to be a trend that's going to be more important in the future than it is now. So trend one, incorporating software plugins. Remember when GPT came out, everybody said, oh, but it won't ever work because it hallucinates, it can't even multiply big numbers. There were many limitations, and still are. But the trend that's important here is that now there are traditional pieces of software, which OpenAI calls, which are accessible to GPT. It knows how to interface to them and call them. There are over 1,000 of these that it has access to. You can define your own too if you're willing to pay a little bit more money to OpenAI. And the bottom line is this really dramatically increases the performance quality of these models. And so, for example, now if you ask GPT to multiply big numbers, it doesn't. It calls Wolfram Alpha, has it multiply the big numbers, and then tells you the answer. And if you want more details, it'll give you a pointer back to Wolfram Alpha, where it will tell you how to represent an area or whatever else you want. Okay, but the point is, many of the initial shortcomings come from the transformer architecture simply predicting the next word can be addressed by getting it to figure out how to call these things. And to me, the most interesting technical aspect of this is that it knows not just how to call them. Anybody can read an API, but it knows when to call them. And that's pretty interesting. I can't personally tell how good it is at that when question, because when you use ChatGPT, it usually asks you identify 3 or 4 or 5 for this conversation. It asks you for help there. So to me, that's probably an indication that there's still a technical issue having it figure out exactly when a diverse library could be useful.
And Tom, I don't know whether this is a separate trend or part of this one. It can kind of iterate. It can go and this is something that's emerging. Call it and then use the input from or the output from that to then do a multi-step sequence, and that makes it even more powerful.
That's a good point. So yeah, it's not just a matter of sort of answering questions, so I'll turn it over. But right, chains of reasoning where the individual steps could come from different sources. Another fun experiment to do, by the way, I've done quite a bit of this recently, is that GPT is pretty good at writing Python code and things like that. I've started asking it to write pseudocode for much higher level problems. So like, write me pseudocode for finding a new job that will only have to work 3 days a week and will be in a tropical climate. And it'll write this pseudocode where it just makes up function names like, collect favorite tropical climates. And, but the reason this is interesting, the reason I'm talking about this, is I think it's an interesting way to probe its ability to do this kind of chained reasoning. And so, for example, if you ask it to write pseudocode for finding a job, it will create a loop that involves you submitting applications, waiting a certain amount of time. If you click some more, and so forth. But this link between its ability to reason, which in general we don't have a very good grasp on, and its ability to code, which is kind of a much crisper thing. It's easier to test how well it's coding, I think means that pseudocode, having it write pseudocode is actually a pretty interesting way of understanding better its ability to reason. Okay, and so there are a lot of these, like trend one. Trend two is actually the inverse of that. Is that the right word? So not only can LLMs call software, but now we're seeing the development of software ecosystems that call LLMs. And so, for example, there are frameworks like LangChain, semantic kernel, and actually these days, OpenAI is even providing development frameworks. But the important point is that these frameworks let you develop software of your own, call out to LLMs as subroutines. And of course, unlike most subroutines that you're used to programming with, these are programs where the API is usually natural language. So it's kind of a big shift in terms of programming paradigms. But it's very important because it means, again, we can get around many of the limitations of LLMs by bringing in more traditional software solutions like databases and long-term memories and so forth. And I think this is, many people think that this is, we're seeing the beginning glimpse of a major shift in software engineering and paradigms for producing software. So let me give you an example. I don't want to go into horrible detail on this, but one example that we've developed in our group, we're interested in online education. So we decided to build an educational environment where students can read some material, but then they interact with a student bot, and their job is to learn the material by teaching it to the student bot. And so you can see here in green, the student bot is saying, hello, I'm eager to learn about cell biology. Could you please explain what the phrase form follows function means in this context? And then the human types in some answer, and then the bot responds and so forth. Then now it's asking, well, can you provide an example to illustrate that? So there's a student bot, which is GPT-4 based bot. And there's a professor bot also, who will step in and help the human if they get stuck while they're trying to teach the student bot. So the idea is, here's an example of a system where software system has a lot of components. But two key subroutines are the student bot and the professor bot, which get invoked at various times by the software. Now, the fun thing is that to program that student bot, here is the program. We just said to GPT-4, you are an enthusiastic 18-year-old student who's trying to learn. You need the user who is to slowly teach you all the topics. You have access to the list of topics, not to the material itself. You must learn one topic at a time. And here is the list of topics you found from the internet that you need the user to slowly teach you. And then here we put where it says transcript, that's where we put in for the particular lesson what the set of issues is. Okay, so that's part one. Part two then says some advice about how it should. You need to learn very little at a time. Ask the user, who is the teacher, teach you the material little by little. If it gives you the answer, you must A, show appreciation, B, insert a smile, and then C, ask a follow-up question if you need more information about the current topic, or ask a question about the next topic. So we're spelling out in pretty much detail how we want the student to behave. But again, this is all natural. This is the entire program for the student bot. And similarly, there's a program like that for the professor bot, telling it when it should, as it's watching the conversation between the human and the student bot, when it should step in and how and so forth, formulate polite and brief comment, and so forth. So I think this kind of system where programming is some weird blend of what I'll call traditional programming, we had to write the user interface, the display code, and calls to subroutines, which are LLMs, programmed in natural language, is going to become pretty pervasive over the coming time. Yes?
So I have a question. So regarding the student bot, I can for the student bot, I see you gave like many different type of prompts. It seems the goal is to make sure that the students have this learning trajectory, etc., like the progress of learning. Do you see that happening in practice if you do this kind of prompting? It feels like simulating how students learn, like the procedure seems very challenging. And that's why probably student bot needs more prompt than professor.
Well, you're right. We don't really understand how students learn or the diversity of ways in which they learn. So here we're just doing our best estimate of how a student bot should behave to be realistic. But you're right. You can imagine, and one of our goals on it, to be honest, over the coming years, is to use data from real students to learn the profile of behaviors and then to reprogram our student bots to follow more of that kind of thing. That's a long story, so I'm going to resist it to get started, but you're on target. Just because it's English and we can say things doesn't mean that we know quite what to say. Okay, so then yesterday, as I was thinking about preparing my slides, I thought, well, let's give an example of today's interface of OpenAI if I want to create an agent there. And so I went in to just ChatGPT, where now you can put a little @ in the name of an agent, an assistant, one of their plug-in assistants you can invoke. But then at the end of the little menu of assistants you can invoke, it says create your own. So I clicked on create your own, and this was the screen that appears. It asks, I'll help you build a new GPT. You can say something like, make a creative who helps generate visuals for new products. What would you like to make? So I said, a weather app that accesses the NOAA website and can answer any question about weather in any location on any day and compare weather in different locations. So it spent a little time, then it says, does the name Weather Wizard sound, how does the name Weather Wizard sound for this? I said, sounds good. Then it built this icon for me for the Weather Wizard. Asked me if I liked the profile. In a different version of this, it gave me one that was way too cloudy, not enough sun. So I told it it's not sunny enough, and then it revised it to make very, very tiny clouds. Okay, and over in this panel, I can try it out. Over here, I say, okay, compare today's weather in LA and Palo Alto. And it did. So you can create your own assistant. By the way, the save button up there takes you to a little, screen like this, where this is going, it wrote the documentation, the instructions for how to use it. It authored that. And this is what it's going to show to people when they invoke this assistant. This whole process took me 5 minutes. So if you have an idea, you can go from idea to GPT assistant in 5 minutes at this point. And then you can publish it either to yourself or to the broader community and advertise its name, and the documentation is there. So very interesting about where this is going to lead us, right? Raises all kinds of questions like, well, let me do it this way. Oops, I don't want to go on to my next. So this is these questions like, what is the future of programming even look like? It's going to be a blend of natural language instructions to Gen AI systems plus traditional coding, maybe? What programming language look like? Python has had a good run, but it's not designed with the idea that you'd have APIs that would be natural language instead of, I mean, it's in the tradition of programming APIs past formal data structures back and forth with formally defined semantics, not natural language. So maybe we're going to see the next generation of programming language be some weird blend of Python-like structured traditional code with natural language. A lot of this will depend on what is the business model for example, for OpenAI and others, in terms of supporting development of these assistants. If you can write your assistant in 5 minutes and rent it out to people and make money by renting out your assistant, then there might soon quickly become a big user community of developers there. But then it raises the same question that you already encounter if you try to use plugins. How do you validate that this plugin is any good? Which of the PDF readers should I use? Right, there are a whole bunch of plugins that can read PDF files. I don't know how to choose the right one. I don't know what kind of infrastructure would help me choose the right one. If I think about the Apple iPhone store, I think about reviews play a key role. How many stars does this have? So it would seem reasonable that maybe a year from now, if the OpenAI store continues like this, maybe we'll see reviews like that. But I don't know, maybe the reviews will be automatically generated by OpenAI GPT-4 trying out all these things, comparing them and critiquing them. It's actually a very interesting set of possibilities where computers might play some of the roles that humans have traditionally played in the Apple phone store. So where that heads. Also, I can't help pointing out, because this seems to surprise some of my computer science friends when I say this, natural language is actually more expressive than formal languages. Right? And they don't like this because they spent a long time learning first order calculus, first order logic and things like that. But you know, you can say in English anything that you can say in a formal, in fact, formal languages are defined in English. And so you can define your own vocabularies in English. And that's how we define things like first order logic. And then you can use them. And so really it's not a step away from formal languages to move to natural language. It's moving to a superset of the expressive power of formal languages. Okay, trend 3, personalized LLMs. Well, ChatGPT, in a very simple example, allows you to type in a few paragraphs about yourself so that it knows to call you Mary or Tom or whatever. It also knows that I'm a professor and that I like machine learning and that I'm a fan of AI. So I'm sure it's using that in some way. But much more interesting and much more powerful, I think, is Google's experimental version of Bard that you can grant access to your Gmail and your Google Docs. Has anybody tried this? Oh, you got to try it. You got to try it. Okay, so here's an example. I tried. I said, summarize my recent emails regarding my upcoming presentation to the US Patent Trademark Office. It searches my Gmail, finds what it believes are relevant emails, and then summarizes for me. It says, you received an email from Ram Kanduru regarding your upcoming presentation. He shared the link to the Google Drive where all the content for the lecture series is stored and asked you to confirm your lecture date by entering initials in column F. He also mentioned that the lectures, etc. And then it gives me a pointer to the emails that it used for this summary.
Are you? That's really impressive. It is tempting because I could definitely use my email summarized. But are you concerned about privacy and like where does this? I guess in some sense Google already has access to all your emails at some level, but I'm told sometimes this information leaks into the LLMs or other people end up seeing it inadvertently. Do you have concerns like that?
So I've looked into this fair amount. Regarding the privacy issue, I'm not concerned. So like you say, Google already has my email. So it's not like I'm giving a new organization access to my email. I'm giving a new piece of software access to my email. Should I care about that? And I would care if I thought that somehow when you logged in, and you said, show me Tom's email, then it was going to show you. But the terms of use assure me that's not happening. And many of the comments I hear people make about privacy and information leakage, I don't understand them well because if you train a model on text, then there's definitely an issue that in the future, somebody could trigger that model to regenerate that text that was trained on. But once it's trained and the parameter values are frozen, then a system reading my email, the only influence that it has is to change the instantaneous values of activation in the network. It's not able to change the parameter values anymore. And then when you start a new conversation with Bard or any of these systems, they reinitialize the values. So in other words, it's a short-term memory state that's basically erased at the end of your.
Like RLHF or feedback? Do they try to get feedback from their users about what works and what doesn't work and use that to improve the model?
That's a good question, and I don't know. I will tell you that the thing that most impressed me is this ability to distill the salient points from the message. What impresses me least and surprises me the most is the weakest point is it often doesn't find the right emails. This is Google, this is Gmail. If anybody should do the right job on searching for the relevant emails, it should be Google. But I'm not seeing that happen.
So there's a lot of stuff recently in New York Times article the other day about virtual reality and harassment and so on. And there's issues about what comes in. These are all personal action, student, professor interacting there. What's controlling it from saying politically incorrect things or insulting people or doing whatever? Is that well understood? Is it just tied into a correct behavior model? What's the reason to expect these interactions to be civil?
Right, so that's a big question. All of these models there's a lot of work going into all of these models on trying to teach them to be civil. One way that gets to the RLHF comment that Eric made a minute ago. So one strategy people use is what they call reinforcement learning from human feedback. And what they will do is they'll get humans to look at two alternative outputs produced by this LLM. And they get humans to say, this one's better than, I prefer this one to that one. And so then they get normal humans, civil humans, to label that data to prefer the more civil answers and to negatively weight the kinds of answers you wouldn't want to see. Much more than that is going on. I don't know all of the technical details, partly because the big owners of these systems are not providing all the technical details. But this issue of how do you constrain these systems to behave civilly is an important issue. One thing I will say, though, is that here's my way of thinking about it, to be honest. I used to think computers were perfect, and therefore if somebody gave me a new program, I wouldn't use it unless they could convince me it was error-free. Somebody gave me a program to multiply two matrices. I am not going to use that unless every single time it produces the right product. But I think in the past 12 months, I've changed my idea. This is a different kind of software. It's more like my crazy cousin or my civil cousin. They're not guaranteed to not say something outlandish, but in the most cases, they say something helpful. And if they say something outlandish, I know how to deal with it. I know how to ignore it or whatever. And so I think our old idea that computers were perfect, whereas humans, of course, aren't, and we know how to deal with humans. But computers are a different kind of thing. We should evaluate them differently. I think we're going to slide away from that when we start interacting more and more with these kind of systems. And partly I think that because I think it's, honestly, my opinion, it's impossible to guarantee that an AI system won't say something that we consider offensive. But if we didn't interact with systems that we thought could say something offensive, we'd never talk to humans. So I think we're gonna, okay, let me move on to another trend. Oh, okay, so anyway, personalized, this trend toward personalization. And by the way, this is going to accelerate dramatically this year, right? Because among other things, Google's Gemini, the nano version of Google's Gemini, fits on a phone. Samsung has announced that they're going to release it as part of Samsung phones this year. So imagine you had a version on your phone and you gave it access to your mail and your calendar, and for that matter, everything that goes through your phone. That would be could potentially be the most useful assistant you've ever had in your life. And we're going to see those kind of systems appear this year in 2024. So it's going to be an important trend for this year. Privacy issues, yes, but see, I think I'm not so worried about them because I think the initial thought, oh my goodness, an AI system has access to my email. Well, Google already has access to your email. It's a question of what the AI system is doing with it. And if Google and Microsoft are smart, then they will put in terms of service that guarantee no leakage. And then I think that'll do it. One here and then Aaron. Yes.
So one of the things that comes to mind when you talk about privacy issues, I mean, I think perhaps it's good that they don't, send your data back, but perhaps more concerning to me is the potential for like behavioral change, where I think what you're looking at here and what's really exciting is with this access to highly intimate data, these models are able to better represent your, for all intents and purposes, like psyche or personality. Like right now, if you go to Google, you can go to their ad features and it'll say like, what do you think about me? And it'll say, oh, you're probably like 18 to 25 or whatever. And you probably live in this area and, don't have a family or something like that. This seems to like take that to the next level. So regardless of whether they're sending your data back, I think the understanding of you as a person is potentially much more intimate than just your raw data. So how do you think about that and towing the line there, especially, as again, if it's being rolled out into your pocket as soon as this year or next year?
Yeah. I guess a lot of this gets to what you think about targeted advertising in general. Many people are offended by the idea of targeted advertising. Other people think, well, it's much better than untargeted advertising. But I totally agree with you that this is going to be targeting on steroids, the ability to build a very sophisticated model of your general interests and what you're up to today. I think even beyond advertising,
for any application. Whether it's like, oh, I'd love to give you an understanding of me, and then I want to give you my health data. How does that change your behavior or, the way that you perceive your own body image or, so on and so forth. You can kind of play that out into a whole variety of different scenarios. Again, targeting, but, not necessarily just the targeted advertisements, I think is.
Yeah.
Perhaps
you're right. It reaches across many applications. The only thing I can say is think about the kind of health applications that we're starting to see on phones. And would you rather have an AI assistant being your health coach? Would you rather have an assistant that knows you thoroughly in the way that you're talking about, or one that knows you the way current systems know you as a health advisor? And then what are those? For me, the answer is if I'm a health advisor, I want them to know me intimately. But then the other question is, well, what are the things other than health advisor where their knowledge of you would not be such a great thing?
Maybe like one last.
Yeah, do it.
Yeah. Okay, yeah. So no, this is really, and I'm gonna kind of basically skip my question because I want to give you a chance to finish. But let me just say, I mean, this is such an important question that you brought up, and I would encourage everyone in the room to think about. I mean, I would build on what you just said to say, what are the incentives? What is Google's goal? What is their fiduciary responsibility to their stockholders, to their advertisers, whoever? Is the agent going to try to maximize Google's profits and ad sales? Is that what it's going to do in the agenda? Or is the health provider going to maximize the drug sales of the company that's sponsoring it? I mean, those may or may not be aligned with what your goals are. And so I think there's a really interesting business model and economic question about how you align those incentives so that when it has this level of power, that it's using it in a way that's in your interest, and what are the, the societal, economic, other forces that we can apply to make it more likely that it's going to try to maximize things that you want it to maximize. Maybe competition will drive it that way, maybe not. But I think that's a set of questions that would be really interesting to research, because I'm convinced by your presentation that it's coming and it's going to be incredibly powerful. I'm convinced by your question that the level of, we already know that social media with really bad understanding of its users has a lot of influence over, maybe not for good in many cases. So imagine that, as you said, on steroids. It's a incredibly provocative research agenda. And I'm not expecting you to answer it right now. I'm just saying it's out there.
Great point.
Yeah.
Great point. I will say, here's another thing to think about. Who will be the big beneficiary? Who will be the big providers of this kind of personalized service? Notice many people use Gmail, Google. Many people use Microsoft Outlook, Microsoft. Who could possibly compete in this space if you're using either Outlook or Gmail? What new entrants can come in and even have a chance to compete under current regulatory systems, which don't require that, for example, don't require that Google makes your email available to other people. In fact, could probably prohibit it. So there's another question about, in fact, one of the themes that keeps coming through to me as I look across these trends is how regulatory and business model issues intertwine with how this is all going to unfold. And like, here's one example that's just very sharp, very easy to see. So maybe this will provide an unassailable advantage to Microsoft and Google. Okay, trend 4. You already knew this one, multimodal models. We looked at this example a little bit earlier, and Google has its own versions now, and with Gemini, and promises some rumor that there's going to be a new version of Gemini this week released. So that this is really coming soon. And it's important, of course, because much common sense knowledge and much of our knowledge about the world is spatial and perceptual. And so some fun questions to think about. What will be the top applications once we have systems that can do that? Like, one of my favorite is going to be taking my phone out, and when I assemble the IKEA furniture there, I put it like this, and it's watching me assemble the IKEA furniture. Or when I'm cooking dinner, it's watching me cook the dinner. It's not just giving me the recipe. It's also saying, it's time to flip the egg. Or it's saying, no, that leg doesn't go there. It goes over on the other side of the furniture. And so our current thought about these systems being good for knowledge work and for things that we can speak or type to them, we need to kind of open up. Another question, similar question, YouTube be an unassailable advantage for Google? Who could possibly train a better model based on video and sound and even conversational exchanges in voice if they don't have access to YouTube?
Hal Varian's pointed out that there's some unimaginably large number of how-to videos on YouTube that explain how to do so many different things, and they could all be actualized.
That's right. They could even be synthesized for your own. I mean, I think I use YouTube videos all the time to learn how to do stuff. I assume you all do too. But it's sometimes like they're repairing a dishwasher that isn't quite my dishwasher. But you could imagine taking that knowledge and taking the manual from my dishwasher and some future LLM putting together a video just targeted to me. Another very interesting question is whether these multimodal models will cause a new exponential inflection point in robotics. So really, one of the hallmarks of the last 5 years has been this inflection point in non-robotic AI. And robotic AI has made positive progress, but nothing exponential. It's just kind of plodding along, making progress. But if you think about why robots aren't what it would take to make a breakthrough in robotics, partly it's common sense knowledge about the physical world. That's what you need to be a good robot. And maybe these systems will have enough of that to trigger, catalyze a big change. Final trend, the biggest trend of all, most important trend of all, is open source. So again, in November 2022, the conventional wisdom was, wow, this is very cool stuff. OpenAI, Microsoft, Google, Amazon will be able to afford to do this, and nobody else. And people like me who are in universities and people like you who are in universities, we're asking ourselves, did we just become irrelevant? Largely in an effort to not become irrelevant, the open source movement has moved in. But interestingly, it has shown that a number of models developed in the past year that are much smaller than these models that we saw developed by the big players. These models can also be very useful in some kinds of uses. It's generally, I think, accepted that GPT-4 and Gemini outperform these smaller portable open source models. But of course, for any given application, the question is often a satisficing question, not an optimization question. The question is, do I have an AI system that's good enough to tell me when to flip the eggs, or good enough to tell me whether I should wear a raincoat or not today? And if one's even smarter than the other one, but they're both good at telling me whether to wear a raincoat, then for that particular application, it doesn't matter. And so the question of how this is going to all play out has a lot to do with what applications we're really going to field and whether the level of competence these can reach will be satisfactory. It isn't necessarily the question of whether they will be equal to those. Although I think there will always be a premium on the best one, because that's where innovations can happen.
I have heard the argument that sometimes the smaller models can be better insofar as they can be trained more frequently and have up-to-date data, or trained on local data that may be more relevant to a particular application. Obviously, they can be orders of magnitude cheaper to run. How important do you think any of those advantages or potential advantages are? And can I pin you down, push you a little harder about, do you see one or the other of these as being, these stories that bigger is better versus having the smaller models? Do you see one or the other of them becoming more dominant in the coming year?
Those are all great points. I'm befuddled about which ones are going to win. I think they will all win in different spaces. Your point about it's easier to train the small ones, it's less expensive to train the small ones, is a good point. I hadn't really thought about that much, but now that you say it, it's true, but it's also true that even though it's hard to retrain GPT-4, and we all get the same GPT-4 when we go there, one way to customize is to retrain. A different way to customize is to, give files of information in different contexts. And so one of the kind of questions at the center of this is there really a big payoff to being able to retrain quickly? Or can you get the same customization benefit, not by retraining, which is expensive, but instead by contextifying? And of course, there's a lot of research trying to figure that out right now. Conjecture is actually that as the bigger models get even bigger and even better, then customization by contextifying is going to win and is going to be, relatively speaking, stronger as these models get better compared to retraining. But
I can think Anthropic has like a 200K token window that they're rolling out, and I'm hearing rumors that Gemini is going to have even larger, so that at some point it becomes, you can put a lot of context.
yeah. Great questions. Okay, I'm going to wrap up. And I'm just going to point out that for this open source trend, it's really the wild card that's going to determine whether we have many or few players. But some of the questions to think about, again, how are the business models of the big players going to influence or constrain the open source movement? For example, if OpenAI has terms of service that says, even if you pay us to use GPT-4, you may not use it to synthesize data to train your own model. If that's part of their terms of service, that's a huge setback to the open source community. And similarly, how will government policies influence this? If you talk to people in the federal government, many people are supporters of open source because they think it leads to a leveler playing field economically, and it leads to faster innovation. A lot of them are worried about international competition. They want faster innovation. But at the same time, they're terrified by how impossible it's going to be to regulate these models if any old person can have one and train it, and the government even has no knowledge that that model even exists. Whereas if they're just 5 or 50 big players, the government will write down their names and their phone numbers on a list, and it'll have an easier time to keep an eye on and potentially regulate that. So there's a huge. All right, I'm going to stop there just because I want to hear from you all. Eric.
Let me get a question from there's a number of questions online. We'll share these with you so there's a question from Michael Vandermeer, who points out that human intelligence is very different from the intelligence in these systems. And so how should we think about these examples of showing the intelligence of the systems? Are they perhaps overestimating the intelligence and that they're brittle in other areas? And what are your thoughts about the ways of benchmarking the models?
I agree with that point that these things appear to be human. I mean, human-like kind of responses, but the intuitions that we've developed around, well, if a human can do this correctly and can do this correctly, then surely they can do this stuff between those two correctly. We all have kind of intuitions of how we evaluate people in their civility and also their capability. And those things seem not to hold so well for these AI systems. So what that means in terms of testing is we need much more thorough testing. The good news is computers don't get bored, people do. So if we have to test them with more thorough tests, the computers will be able to put up with it, but we really need to think that through. So I think it's a great point.
All right, let me take another one from online maybe. Talking about accuracy, you talked about maybe, you're evolving to not be expecting it to be perfectly accurate. Can you say more about what kinds of tasks AI systems are more likely to be accurate versus less likely, or where we should be expecting them, and where we should look for hallucinations, and that kind of spectrum of accuracy versus error?
I like the question. I honestly think I don't trust my intuitions on that. Places where I have been surprised to find errors are I often use GPT and Google's Bard to learn about technical things I don't know about. And I've been disappointed and surprisingly disappointed several times by the ability of both of those systems to just make up papers that don't exist. And then authoritatively tell me what's in those papers. I once asked I gave it one of my papers and I asked it, what's the best follow-up paper to this? And it made up a paper by me. And it said, oh, well, that would be the 2018 paper by Tom. And I never wrote that paper, so.
So let me ask a follow on that. So there are some paths towards, well, there's let me say 3 paths. So one is we just get used to it, which, another one is that the LLMs do seem to be having fewer errors as they get better. And so maybe some people think the hallucination rate is going to get down just organically. And then the third is what you mentioned, calling on other systems. So you can have RAG systems that call on a bibliography and check the references that are, from a database or call a calculator. Do you have thoughts on those different paths to dealing with hallucinations and error and where we're going in the coming years?
Those are 3 great paths. The one I use the most is tracking down the citations. And I think it's a huge step forward when both Bard and GPT started putting those little footnote or quote mark or whatever those things are that you click on to get back to the source material. That's huge. And after a while, I've kind of learned for these topics, I no longer check the citations. But if it's a new topic I haven't had experience with, I still do. Maybe that's similar to how I deal with people.
Okay. Well, thank you very much, Sean. We're out of time, but I appreciate you sharing that. There are other questions online. We'll save those for you, and I'm sure other folks have questions. Let me just remind everybody next week, February 12th, back in the Gates building, room 119, for those of you who are here. Our speakers will be Neil Thompson from MIT. He'll be talking about beyond AI exposure, which tasks are cost effective to automate with computer vision. So hopefully see you then, either online or over in Gates. Thanks very much.
Thank you.